Good afternoon and welcome to Master Talker online class. Today we'll be talking about a topic called vector analysis. Okay. Now the first thing we'll look at is you represent vector in magnitude and direction with an arrow, like we did in the former video on vectors. Okay. But there's another way you can represent vector. You can represent it in its unit. Okay. Now let me say we have vector. The first one we have is vector in a line. Vector in a line. Okay. Now if we have just if we say that a vector is on x-axis, okay, we have x, y, and z, for instance. That is how we have representative vectors in I, j, and k. Okay. So if we say that a vector is vector in a line, just a line. A line is what? Just one. It could be just I, that is a line. And if you see that a vector is in I, it means that that vector is in x-axis. If that vector is just j, it is in y-axis. And if that vector is just k, that vector is in what? In z-axis. So you need to know it. This is how x came first before y before z in the alphabet. That is how I, j, k according to alphabet. So if you see I, know that that vector is vector in what? X-axis. If you see j, vector in y-axis. K, vector in z-axis. Okay. So we say that if we say that the unit of a vector has a magnitude of 8 along the x-axis. We just say that that is what? 8i. That's all. And if you say that a vector has a magnitude of minus 10 in the y-axis, it's going to be what? Minus 10 what? J. And if you say that a vector has 1/2 along the the z-axis, we say that is what? 1/2 what? K. As simple as that. Okay. So the next thing we are going to look at is vector in a space. Vector in surface first. Vector in surface. Vector in surface. Okay. Now whenever you have vector in surface, vector in a line is just one, but vector in a surface is two. That is x and y axis. In fact, vector in a line is just x axis. Just take it as that vector is only on the x axis. Okay. So but if it is now x and y axis, this is y and what? X axis. We say that this vector is in what? Is in surface. For example, if you have 3i plus 2j, okay, so this vector is in what? Is a vector in a space. Why? Because it has both x and y axis. Okay. So the next one we're going to talk about is we can get the magnitude of this. We can get the magnitude of vector in a space. Let me say that this vector a is equal to this. So the magnitude of it, will still come to that. But the size of this vector, or the magnitude of vector, is equal to a squared is equal to. Whenever you hear magnitude or unit of a vector, remember Pythagoras theorem. Okay. So the unit or magnitude of vector all squared is equal to what? 3 squared plus 2 squared. What do we have? That a squared is equal to 9 plus 4. So a is equal to what? 13. So sorry, a now is equal to what? Square root of 13 units. Okay. So that is the size of this vector. This is the size of this vector. Okay. So that is that. Now the next one we're going to look at is vector in a space. Vector in a space. Now, if we have vector in a space, that is when we have the three components. That vector is in three components: x, y, and z axis. So we have it like this: vector in a space. Okay. So we're having x, y, and z. Now don't forget that what? We represent x as what? I, y as what? K, and z as what? J, and then k. Okay. So that is that. So we can say that if you have that vector a is equal to maybe 2i plus 3j minus k, what do you say that this vector is? This vector is what? Vector in a space, because it has three components. Remember, if it has two, it is what? Vector in a surface. Then if it has one, it is what? Vector in where? Vector in a line. Okay, so please don't forget. So the magnitude of this, don't forget Pythagoras theorem. The magnitude or the size or the unit of this vector is what? This is equal to what? The square root. Okay, let me just do it like this. 2 squared plus 3 squared plus minus 1 squared. We are just taking their coefficient. So I'm having a what? A squared is equal to 4 plus 9 plus 1, right? So I'm having square root of I'm having 14, so A becomes what? The square root of 14 units. So this is the size or the magnitude of this vector. Okay, so that is that. So the next thing we're going to look at is what? Unit vector. It's not the unit, sorry, it's the magnitude, please. The magnitude or the size of that vector. In fact, let's talk about magnitude of a vector. I just did it once, but let me just, as you're writing your notes, so you have it. Magnitude of a vector. Magnitude or size. You can call it size of a vector. So if I have that vector A is equal to xi plus what? yj plus what? zk. So we want to find the what? The magnitude. The magnitude will represent it like this. Magnitude of this is equal to the square root of only their coefficient, x squared plus y squared plus z squared. Very important formula. Okay, so an example to that. Example, find the magnitude or size of the vector A, which is equal to minus 3i plus 2j minus k, something like this. Okay, so I have this. What do I say? Solution. We tell them that the magnitude of A all squared is equal to what? Minus 3 squared plus 2 squared plus minus 1 squared. So what do we have? Magnitude of A all squared is equal to 9 plus 4 plus 1. Okay, what do we have? A squared is equal to what? 14. So A, magnitude of A is now what? Square root of 14 units. Okay, so that is that. So the next thing we are going to look at is what? Unit vector. The next we are going to look at is unit vector. Now, how do you get the unit vector? We represent unit vector like this with a cap. Okay? We represent it with what? With a cap. So I have that what? The unit vector of A like this, represented like this, is equal to what? That vector itself all over the magnitude of that vector. As simple as that. It's a very simple formula. Okay, look at an example. Example says find the unit vector of vector A, which is equal to 2i minus 3j plus 2k. Okay, look at this, very simple. So what do we do? Remember that this is vector in what? Since there are 3, this is vector in what? In a space. If there are 2, it is what? Vector in what? Can you remember? Okay, it is called, sorry, vector in a surface. We have vector in a surface, vector in a space, and vector in a line. Okay, vector in a line is one component. Vector in a surface is 2 components. Vector in a space is 3 components. Okay, so what do we do now? We'll now say that the first thing to get is their magnitude. So if I get the magnitude is equal to what? 2 squared plus minus 3 squared plus another 2 squared. So what do I have? A squared is equal to 4 plus 9 plus another 4. So what do we have? Magnitude of A squared is equal to 4 plus 4, 8. 8 plus this is 17. So what do I have now? The magnitude of A is now the square root of what? 17 units. This is the magnitude. We are not looking for the magnitude. We are looking for the unit vector. Okay? So the unit vector the unit vector A is equal to what? The vector itself, which is what? The vector itself all over the magnitude of that vector, which is equal to what? 2I minus 3j plus 2k all over what? The square root of 17. That's all. Okay? So which can be written like this. Sometimes they will write it like this. Share the root of 17 to everybody. It's going to be 2 over the root of 17I minus 3 over the root of 17j plus 2 over the root of 17k. Okay, sometimes they will put it in this form. Okay, that is for magnitude, the unit of a vector. So the next thing we are going to look at is okay. Okay, the next one we're going to look at, they said if vector b is equal to minus I plus 2j plus 4k plus 4k. Okay, they now say find the unit vector of vector A, vector B. Okay, so what do? We tell them that what the first thing we are going to find is what? The magnitude of vector B, which is what? Minus 1 all squared, because there is no coefficient here. Minus 1 all squared plus what? 2 squared plus what? Okay, sorry, this is 0. This is 0, sorry. Plus what? 0 squared. So what do we have now? 1 plus what? 4 plus 0. So what do we have now? We have 5. So the unit vector now becomes what? The square root of 5 unit. Sorry, the magnitude. This is the magnitude. So the unit vector of vector B becomes what? Vector B itself. We represent any vector with arrow. I hope you remember. All over the magnitude of vector B, which is what? Minus I plus 2j plus 0k all over the square root of 5, which can be written as minus 1 over root 5 I plus 2 over root 5 j plus 0 over root 5. 0 over something is 0 plus 0k. So that is that. We move to the next one. Okay, so let's move to addition and subtraction of vector. Addition and subtraction of vector. Addition Now, how do you add or subtract a vector? We add or subtract a vector according to their component. So x component add x component, y component add y component, and j component add j component. As simple as that. That is I to I, j to j, k to k. And what we are adding is only their coefficient. We are adding or subtracting only their coefficient. Okay? So an example said if vector A is equal to 3I minus 4j plus 0k, and the vector B is equal to 2I plus 3j plus 2k, and vector C is equal to 4I plus 2j minus k. Okay, then I say find the unit vector of vector m, which is equal to a minus b plus 2c. Okay, they gave us this. Now the first thing we need to find is that vector m. So how do you find vector m? Solution: vector m is equal to, by doing this thing now. So let us do this. We have a to be 3I minus 4j plus 0k, then minus bracket b is what? 2I plus 3j plus 2k. Okay, and then finally plus 2 bracket c is what? 4i plus 2j minus k. As simple as that. So let us open. My vector m is equal to what? 3i minus 4j, okay, plus 0k, minus time this will give you minus 2i, this time this minus 3j, this time this minus 2k, this time this plus 8i, this time this plus 4j, this time this minus 2k. Okay, now if you look at this, don't look at this as a vector again. Look at it as normal mathematics, that I must like terms will only add or subtract. So I will look for the like terms. So 3i minus 2, in fact let me bring everybody that has I. 3 is here, this one is what? Minus 2. The last one there is what? Another I. 8i, is it? Yes, 8i. So plus 8, and everybody has I like this. Or you do it like yourself by saying 3 minus 2 then plus 8. Any answer you get, write it. But I just want to show you like this, okay? Plus like this. You must put plus, open bracket and start again. J started with minus 4. Put it there, minus 4. Another j minus 3. Okay? Another j again. Another j here is plus 4. You close and everybody has what? J. Okay? Plus again. The plus must be there. You open again. This one is 0. Okay? Minus 2. Another k again. Minus 2. And all of them has k. So you can now get your final answer to be what? 3 minus this is 1. 1 plus this is 9. I'm having 9i. Okay? Don't go and say 2 plus this 10. No. This 2 has this minus, please. You can only say minus 2 plus 8, which will give you 6. 6 plus 3 is 9. Okay? Please be careful with minus. Plus, let's come here. Minus 4 is gone. So I'm left with minus 3. So that minus plus will give you minus. So here we change to minus 3. Minus 3j. Okay? Then here I'm having minus 2 minus 4. So I'm having minus 4k. Okay? I have gotten my vector m. So now let's get the magnitude of vector m, so that we can use it to get the unit of vector m. So magnitude of vector m is equal to our normal formula. The square root of, let me do it once. The square root of 9 squared plus minus 3 squared plus minus 4 squared. You see that? So magnitude of m is equal to the square root of 81 plus 9 plus 16. So what do I have? So this is 90, 106, 106. Okay? So this is what? The unit. Sorry, this is what? The magnitude, which is the size of vector m. So the unit of vector m, which is m cap like this, is equal to what? That vector m all over the magnitude of vector m, which is what? Vector m is 9i minus 3j minus 4k. Minus 4k, okay? All over the what? The root 106, okay? You can separate them if you want. Okay? So that is that. The next thing we are going to move to, we have done addition and subtraction. So alright, so now position vector. Position vector. Position vector. Now, the position vector of the point P is the vector from the origin to the point P. Hence, position P is the displacement between the origin and the point. Okay? So now the displacement or the distance between 2 points, okay? The distance between vector A and vector B is simply by subtracting. Simply by subtracting. Okay, so what do I mean by that? They said, let me give you an example. Okay, just know that the position of a vector is the point, the displacement between that vector and the origin, that is 0. Okay, but from there, let me show you how to get displacement of a vector. Displacement of vectors. Okay, let's say find the displacement of the displacement vector from the position P1, which is 2, 4, minus 5, and P2, which is 4, 3, 2. Okay, so what do we do now? So the position of this vector, the displacement between this vector is what? The P1, P2 is equal to, this is the distance between them, but we call it displacement because we are talking about vector. Okay, but if it's a scalar, we call it distance. Okay, so but I'm just using the word distance for you to understand. It's just by subtracting the components. Subtracting the component from point P1 and to point P2. Okay, so it will be 2 minus this. In fact, let me write it at P, which is what? Let me say vector P2 minus vector P1 so that you can remember. Okay, so and you know that all these things are in their components. So you know that this is what? I, J, and K. I, J, and K. So let us start. It's going to be 2 first before 1. So you say 4 minus 2, put their I. 4 minus 2, put their I. Then the next thing is what? Plus is always in the middle. So you start again. 3 minus 4, you put your J. Plus is always in the middle. Then you have what? 2 minus first before you have minus 5. K. Okay, so what do we have now? This minus this will give you 2i. This and this will give you minus j. So plus minus will give you minus j. Why do we always put plus here? Because plus does not affect anything. That's why we always put plus in the middle. Okay, minus minus is plus. This plus this will give you 7k. 7k. Okay, as simple as that. So we can get the magnitude if we want. We can get the size of it. We've gotten the displacement in terms of vector. We've gotten the what? Vector displacement. But if they ask you just the vector, the vector, which means get the size of that, if they ask you the size or the magnitude of the displacement, so you know how to get magnitude. So the magnitude of the displacement, okay, should be equal to what? The square root of 2 squared plus minus 1 squared plus 7 squared, which will give you the square root of 4 plus 1 plus 49. So I'm having the square root of 54 units. So that is that, the square root of 54 units. Okay. So the next thing we are going to look at direction cosine of a vector. Direction cosine of a vector. Direction cosine of a vector. Okay. Now, from the word direction cosine of a vector is simply, if I have vector A, which is equal to what? Maybe let me say xi plus yj plus k zk. Okay, the direction cosine is always on each particular component. Okay, on each particular component. So I can call it cos alpha. Let me use alpha for this one, beta for this one, and gamma for this one. So direction cosine of the first component here is what? Alpha is equal to what? X over the magnitude of that a. Okay, that is that. Then cos beta is for the second one, which is what? Y over the magnitude of that a. Then finally the last one is what? Gamma. The last one is gamma. That is cos gamma is equal to what? Z over the magnitude of a. As simple as that. So all these things are very, very simple. The problem is for you to remember the formula. That's the problem. But if you can try, you will remember it. So they say find the direction cosine. Even from the word cosine, you know that you will use cos. Okay, cosines of the vector a, which is equal to 2i plus 4j plus minus what? Minus 4k. Okay, so in fact, for you to get direction cosine, I would advise you first of all get the unit vector of that vector. So let's get the unit vector of this. So getting the unit vector, first of all, you need to get the magnitude. The magnitude is equal to the square root of the first one, 2 squared plus 4 squared plus minus 4 squared. Okay, so I'm having the square root of 4 plus 4 squared is 16 plus another 16. So what do we have now? So I'm having 16 plus 16 is 32 plus 4, 36. So I'm having the square root of 36, which is equal to what? 6. Now, the unit vector of this vector is equal to what? The vector itself all over the magnitude of that vector. So how do we get that? It's equal to what? 2i plus 4j minus 4k all over 6. So I can share it for them to be what? 2 over 6i plus 4 over 6j minus 4 over 6k. Okay, so from here I can now easily get their direction cosine. So for the first one, I'll call it what? Cos alpha is equal to what? 2 over 6. This one, comma. Cos beta is equal to what? 4 over 6. And what? Cos gamma is equal to what? Minus 4 over 6. You see? As simple as that. So now, to get their, you are not stopping here. To get the direction cosine, the direction of this one, direction means the angle it is going. So the direction should be cos inverse of any answer you get here. So please, don't forget. Okay? Permit me to solve it here. So since I have cos alpha is equal to what? 2 over 6. So the direction of vector I should be what? Alpha, which is what? Cos inverse of 2 over 6. Are you getting it now? So the other one for beta is what? Cos beta, which is for j component, is what? 4 over 6. So the direction of that j component is what? Cos inverse of that 4 over 6. Okay? Then the last person is what? Cos gamma is equal to minus 4 over 6. So gamma itself should be what? Cos inverse of minus 4 over 6. Okay? So therefore my alpha is equal to 70.5 degrees. My beta is equal to 48.2 degrees. And my gamma is equal to 131.8 degrees. So that is how to get the direction. That is why it is called direction cosine. You need to get the direction, the angle where that thing is going. That is the direction. So the angle of each of these components is called direction cosine. Okay? The angle of each of these components is called the direction cosine. So that is how to get that. So unit vector can easily help you to get it. So the next thing we are entering is product of two vectors. So okay, it should be in our next class because of time. So thank you very much for watching this particular one. God bless you. Please like, share and drop your comments. God bless you.